So now this is this video is now 18 months old. So this is Pager, who is playing monkey mind pong. So this is Pager has a Neuralink implant in this video, and the thing that's interesting is that you can't even see the neural implant. So we've miniaturized the neural implant to the point where it matches the thickness of the skull that is removed. So it's essentially it's sort of like having an Apple Watch or a Fitbit, replacing a piece of skull with like a smartwatch, for lack of a better analogy. So you can see, he looks pretty, he's normal. And I think that's pretty important. If you have a Neuralink device, like I could have a Neuralink device implanted right now, and you wouldn't, you wouldn't even know. I mean, hypothetically, maybe one of these demos, in fact, one of these demos I will. Yeah. So yeah. Anyway, so here's I mean, first of all, it's kind of wild. Hey, monkeys can play Pong. They can actually play Pong if you give them a joystick. So Pedro first learned to play Pong with a joystick. So I'm like, that was novel. It's like I didn't know monkeys could play Pong, but they can. And then so we first trained Pedro to play Pong with a joystick. Then we took the joystick away and have the Neuralink, and now he's playing it's telepathic video games essentially. And here you can see Sake, it's one of our other monkeys, typing on a keyboard. But now this is telepathic typing. So to be clear, he's not actually using a keyboard. He's moving the cursor with his mind to the highlighted key. Now technically, we can't actually spell, and so I don't want to oversell this thing, because that's the next version. But what's really cool here is Sake the monkey is moving the mouse cursor using just his mind, moving the cursor around to the highlighted key, and then spelling out what we want to spell, but being able to demonstrate full reversibility and upgradability, so you can remove a device and replace it with the latest version, or if it stopped working for any reason, replace it. That's a fundamental requirement for the device at Neuralink. Even if someone has never had vision ever, like they were born blind, we believe we can still restore vision. Because the visual part of the cortex is still there. And then I want to emphasize again that the primary purpose of this update is recruiting.
Our initial goal is to help people with paralysis from complete spinal cord injury regain their digital freedom by enabling them to use their devices as good as, if not better, than they could before the injury.
We started this project with our monkeys, but of course they don't know how to write. So to mimic writing, we train Ranger, one of our favorite monkeys, to trace digits on an iPad. It requires hundreds of examples and samples of each of the digits and the characters we wanted to classify. This would not scale. The way we are solving that is by indirection. Instead of decoding directly the digits, we first decode the hand trajectory on the screen. And then, when we decoded the hand trajectory, we can use any off-the-shelf handwriting classifier to predict the digit and the characters. For example, classifiers that are trained on an MNIST dataset. Why it's so important? It's important because now we can potentially decode any character in any language with only one neural decoder for hand trajectory.
Our current production charger, which charges our current generation of implants, is implemented in an aluminum battery base, which also includes the drive circuitry. a remote coil 4 times the size of our original device, also disconnectable.
Well, we have started work on our 4th generation system and have totally redesigned it from the ground up to be a hot swappable, single implant per vessel design, partly inspired by high-density compute servers. With this new system, we will achieve a whole new level of density, robustness, and scale. We also intend to have many of these systems operational in the pursuit of capturing even the lowest frequency edge case failure modes. With this, we will have thousands of implants testing in pursuit of these goals.